Hey everyone, welcome back to another video. So for this video, we're going to be doing some more classification stuff. And so what I have planned for this video is I'm going to be working with kind of a similar data set from last time, except it has a little bit more variables in it, including Kirby data and also just some more artificial variables I made that include productivity as well. And so let's just go ahead and get into the data set really quick. So here's the data set right here. And so as you can see, we have the same UPH variable as last time. Total units shopped, total shop time. What's this one? Average minutes per retrieval. That's a new one. That's just basically how long, the average amount of time that this partner is taking to basically close out an order whenever they Kirby it. And this one right here is total orders retrieved. So this one is just how many Kirby's did they grab for the week. And then total retrieve time. This is just in minutes, basically total amount of time they spent in a Kirby run. And then sub and short percent, same thing. And then productivity. So this is an important one here. So this is basically a productivity that the partner had for a current week, just basically rating the partner about how efficient or how productive that partner has been. And so as you can, we're not going to be working with this column, this color column here, for this classification thing we're doing. But I'll go and explain it really quick. And so what it is basically based on their productivity, the partner is assigned a color, and so it goes from red being the lowest, and then goes yellow, orange, green, and blue. Blue being the highest. And so anything below, I believe, anything below 85% is red, and then anything below 90 is yellow. Anything below 100 is orange. Anything below 110 is green, and then beyond that is blue. So, what we're going to be doing for this classification is we are going to build a model that classifies whether or not partners need to be coached. And so, what I did is this is an artificial column. And what I basically did is just I did another if statement, and it's solely based on their productivity. I did if their productivity was below a 90%, they need to be coached. And so what 90% does is it grabs all the partners from the bottom two colors. So normally we don't get onto partners for being in the yellow. It's all mainly only the partners on the red, which we usually have a lot of partners in the lowest productivity. But this is just to balance out the amount of partners I have in my needs to coach or don't need to coach. So it's just to even it out. And maybe this could just be a way where if we're classifying people that we need to coach, we can just, if they're in the yellow, we can just tell them, like, hey, like you're getting close to the red. We just need just letting you know, basically. So, and whenever I'm doing my classification, because this coach column is solely based off of productivity, I am not going to include productivity as my predictor variable, one of my predictor variables. What I'm going to do is I'm basically using, these are my predictor variables I'm going to be using. They're all just continuous numerical variables. And um, I think that's pretty much it. The reason why I'm not including the productivity is just because, one, to make it too easy. I don't want to cause any data leakage. Just because of how strongly it predicted how strongly productivity is correlated to the coaching. Oh, sorry, we got a guest visitor. Give me 1 second. Come on in. Come on in. Well, everyone, you get to meet Rocky. Rocky is my personal cat. I love him to death. I guess he's really interested in learning about classification models for machine learning. So he's really excited, obviously. So he's gonna join in with us. So everyone say hi to Rocky. He's my new mascot. Okay, back to it. So basically, yes, we're going to be classifying whether or not new partners need to be coached, given these columns that I've highlighted right here. Okay, and we're just gonna be using R, like last time. Okay. So what I'm going to, and also I should mention also, like last time I already written down the code. This one I'm going to be writing the code alongside y'all. So if y'all want to follow along with either the same data set, if like I ever send it to y'all, or if y'all, Rocky, you're making my allergies bad. Or if you prefer to just do it with another data set, y'all are more than free to do so. Okay, so let's first load our data. Okay, so let's load our data in here. Let me copy the file path really quick. Give me 1 second. Let me make sure this is saved. Okay, we don't need this anymore. Just copy the path. Okay, here we go. And I don't know if I mentioned already, but I'm going to be doing 3 classification models. I'm going to be doing a logistic regression, I'm going to be doing a classification tree, and I'm going to be doing a random forest. Just basically, we recently learned these 3 classification models in my machine learning class, so I'm just going to be doing some practice alongside y'all. Also, just one thing, I'm already kind of expecting the confusion matrix to not really show that high accuracy, just because it's already know what the coaching column is based off of. So I'm just trying to challenge the machine here and to be able to, I guess, see a pattern, just strictly looking at the performance variables. So that's what we're going to be doing. And just productivity is just overall a very noisy form of like calculation whether or not partners are being efficient. So let me just load the data really quick. We'll just make sure that everything looks correct here. Let's get the head of the data. Alright, so as you can see, we got all of our columns here. In coaching, as you can see here, it's still off of yes and no. What I'm going to do is I'm going to do a quick miniature data pre-processing, and I'm just going to change that into a dummy variable. And if you don't know how to do that, I'll just show you really quick. So we're just going to call this data pre-processing. And what I'm going to do is I'm going to call that column from my data. It's called coach. And to do this, we're doing an if-else statement. So if-else, we're doing if data of the coach column is equivalent to, let's do yes, then it's going to be a 1. Anything else, it's a 0. And let's just do the head of the data after this to make sure that worked. Perfect. As you can see, our coaching column is now just dummy variables representing whether or not they need to be coached. So 1 from here on out means that the partner does need to be coached, and 0 means that they don't need to be coached. So now let's partition our data. So for our classification, we obviously need to get a validation set and a training set. For this one, I'm going to do a 60-40 split, 60% training of my data, and Rocky. He's just really excited. Okay. We're going to do a 60-40 split, data partitioning. Make sure y'all can see everything. I can't see my keyboard, Rocky. Okay, so let's just get how many rows we have in our data. So number of rows of data. Okay. Perfect. Now let's do our training index. So for this, what we're going to do is we're grabbing a sample from our data of 1 to n being a number of rows, and then the size is, we're doing a 60 split, as I said, so times n, which is our number of rows. Perfect. Okay. And also, if you're just working along with me and you prefer to do like a 30-70 split, that's totally fine. I'm going to be honest, I'm very new into machine learning, so I don't know what exactly is more effective. Just based on like research I've done on my own, a lot of people do a 70-30 split, but this is just this is what my instructor has taught me in my machine learning class. This is how we do all of our data partitioning. I'm assuming a lot of it also has to do with the size of the data, so I don't know. So this is the training index. So now let's apply this to our training So we're going to call it our data and then our training index. Okay. So what this is our training set, and then we're going to call our validation set, and we're going to apply the training index, the negation of the training index to this. Perfect. Also, if we just want to like make sure that the dimensions look correct, we can just do a quick little dimension of train and dimension of our validation set here. Ow. If y'all want to see Rocky here, I'm gonna angle my camera down so maybe you can get some quick, cute little pictures of Rocky here. So dimensions. Let's just load this really quick. All right. As you can see, it's about 60, 40. For our training set, we have 107 rows of data. Oh, I forgot to set my seed. Whoops. Give me 1 second here, guys. My bad. Just in case we're wanting to do this again another time. Let's just run that again. Okay, perfect. So 107 rows of training and then 72 of the validation. So now we're going to get into our logistic regression. And if y'all want, I can pull up a quick picture of a logistic regression. Give me 1 second. Perfect. Okay, this is what we want. This is good. Okay, hopefully y'all can see this okay. So this is a logistic regression, and so basically if we're working with a binary dependent variable where it's either 0 or 1, this is what it will look like. And so in order to the most effective way to draw a regression line in between these, I guess essentially columns, is to do a logistic regression line. As you can see here, that's what this is. So that's what we're going to do, and then we're going to test the accuracy of it with the confusion matrix. All right, let's just exit out of that. We don't need that anymore. Okay. Okay. Logistic regression. All right, so this is our logic model. And then for this, we're going to use the GLM function, which is just the it's essentially just the function to do a logistic regression. And as you see, I already wrote the column we're predicting, and so you basically just do this approximation sign, and then the period just means that we're doing all the variables. Oh, okay. Give me 1 second, guys. I'm going to remove. This is what I'm going to do. I'm going to do a couple steps back really quick. I'm so sorry about this, guys. We're going to make a data frame really quick. I'm just going to remove the columns I'm not needing. So I need 1, 2, 3, 4, 5, 6, 7, 8. So sorry guys, give me 1 second here. Eight. Whoops, I don't know what the heck happened there. You know, guys, I'm only human too. I'm also just I'm not an expert. Also, I'm just trying to apply what I'm learning. 10, 11, 12, 13, 14, 15. Wait, what? Just do the head of the data frame. Make sure that looks good. I just want to see what columns I got. Okay, I don't need 10. Okay. I do need 11 though. Okay, whoops. Let's run this really quick. Make sure that looks good. Total trees on DSS, CSS percent code, classification. Okay. That looks good. Perfect. Rocky. And then we're just going to change this really quick. Data frame, number of rows. Okay. Rocky, I can't lock in if you're constantly hopping up and down. He's just upset with me because I messed up here. But you know, this just shows that I'm doing this along with y'all. Okay. Head of our data frame. Okay. So we just basically eliminated the columns that we don't need. I'm not doing anything with the productivity or the color column. So those aren't there anymore. We just have all of our numerical data and then our predictor, one we're predicting. And we got the dimensions of our model. So that's all cool. All right. Now let's go ahead and now do the logistic regression. So I'm just gonna Rocky. So the GLM, doing the code. Your claws, Rocky. And then doing that. Our data, we're using our training data, and then because it's a 1 or 0, it's a binomial. Okay, I'm gonna get a blanket. Your claws are hurting me, Rocky. Here you go. Okay. Equals binomial. Okay. Whoops. I don't know why that's a. So if we just want to get like a quick overall look at what the summary is of this model. Summary of our logistic model. There we go. So as you can see, we don't have a lot of significant variables here. You know, that's fine, you know. Like I said, I was expecting it just because our coaching column is very obviously off of the productivity column, just because that's what I'm solely basing the coaching variable off of. I didn't do anything else. So I'm just trying to see if any way it can accurately classify whether or not a partner needs to be coached. Only looking at their performance and not their productivity. I guess that's a good way to put it. Okay. So, so now let's predict it really quick. So, we're going to we are going to be predicting our logic model. Well, I can't type. New data is equal to our validation set, and then type is equal to our response, or a response. My bad. Okay. I don't think I did run that, obviously, because it worked. I think that looks good. And now we gotta classify it though. I guess there's another thing I have to do now. I'll explain it really quick before I do it. I actually see my co-pilot's already kind of writing it out for me. But essentially, whenever you do a logistic regression model, it's giving you a probability of what it's going to be. If it's above 0.5, it's going to be assigned a 1 value. If it's below or 0.49 or equal below, sorry, it's going to be assigned a 0. So that's basically what this Copilot is already assuming. It's already know what I'm wanting to do. But doing if else statement, if the logic prediction is greater than 0.5, it's 1. Anything else is 0. So let's just go and take that out. If else the logic predict greater than 0.5, 1, else is 0. Okay, so now that we did that, next thing we're going to do is we're going to build our confusion matrix. So our confusion matrix, and all this is just a table, and then we're doing our predicted is equal to our logic prediction class actual, and then we're just basically pulling from our validation. And then if we want to check the accuracy, we can just do the mean of where the logic prediction class is the same value as the coach. Alright, so let's see how it did. Okay, you know, it's not that bad. You know, 71%, that's honestly better, a lot better than what I was thinking it was going to be. So I guess what I can think of is, you know, it's doing better than I thought. Even though that my coaching column is strictly based off of their productivity percent, now what I can infer is that the productivity is not also just strictly how much they're working. And maybe some of it has to do with the performance as well. I'm gonna be honest, I don't know how they measure productivity. I'm assuming how they measure productivity is strictly based off of time, like how much time they're spent on a run or doing an audit or doing a Kirby. Like anytime they're not doing any of those things or they're not in something on the phone, it's basically making their productivity go down. So that's how I'm assuming how it works. And so this kind of signifies, okay, maybe even though productivity is strictly based off of what I just said, maybe like partners who typically have a higher efficiency or like skill, basically, if they have more skill, it kind of correlates to them not really needing to be coached. And one thing I'm also seeing is that it really over predicted partners. It said they don't need to be coached, but they did need to be coached actually, and it was actually really low. I mean, really high. They like mistakenly classified that a lot, and so what I'm assuming what that is kind of like what I just said. Those are probably partners that had really good stats, like really high UPH or lots of unit shots, but they're just not effective workers. So like they might do really good on run, get it done fast, get a lot of UPH really high, but then they will just like stand around and not do anything for a really long time, and so that's why it makes them in the really unproductive section. So I'm assuming that's probably what that is. That's probably why it's misclassifying that very large amount. Other than that, it classified pretty accurately. So now what we're going to do is we're going to move on to the classification tree. And so what a classification tree is, the effectiveness of it is that it's really easy to interpret. What it does is it builds a tree using your predictor variables, and basically if the criteria meets the first condition, like yes or no, it will go down the tree until it finally chooses how to classify them. I know it kind of really sounded confusing. I'm not the best at explaining it, but let me just load in what I need for it. So I need R part, and I'm also going to do the R. Oh, I can't spell. Don't mind me, everyone. I'm using my clanky keyboard here. Library. There we go. All right. So for this, we're doing a classification tree. The downside to these, though, is that they tend to be less accurate. So let's see. I'm kind of scared, honestly, just because our classification accuracy for logistic regression is already low enough. So let's see how much lower it can get. Okay, so tree model. We're doing R parts, and then basically it's following the same format. We're predicting our coach variable off of that, and then our data is still equal to our train, and then method, since it's a classification tree, we have to specify that it's equal to class. Okay. Rocky. like you got bored, everyone. I'm sorry. Hopefully, I'm not too boring for y'all. But let's move on. So now what we can do is that we can basically plot our tree. So we can do our part, um, plot, and then our tree model. So we can see what it looks like. I guess I'll run it really quick so y'all can see. I won't get to the accuracy just yet. And here we go. We have this is a classification tree. I think I have an image already of one on here. Yeah, here we go. So we can get, so y'all can see a better picture of it. Hopefully y'all are able to see this okay. Let me zoom in here. Okay, there we go. So this is a classification tree, and so as you can see, the first one is based off of UPH. It says greater than or equal to 131. And so for this tree, if they have a very high UPH, it automatically just assumes that they don't need to be coached. And that's probably what's happening whenever in the logistic regression, it automatically said they don't need to be coached when their partners actually did need to be coached on productivity. It probably was already looking at their like above average UPH and was automatically assuming they don't need to be coached, which they do. So that's probably what's happening here as well. But if they don't have a UPH above 131, it goes over to this part of the tree. And so basically after that, it goes off of total orders retrieved greater than or equal to 27. If it is greater than or equal to 27, it goes over here. And then if their total retrieve time is less than 269, which that's kind of odd. I would assume that if it was, okay, that's really weird. I don't know why it says that. That's not really, I'm kind of scared now. But being below, the higher the better of total retrieve time in this case. That means that they're being more productive, I would assume. But maybe I just need to do, I should have done like a variable flip or something. I don't know. But, you know, it's okay. We're going with the flow here. So this is how a classification tree looks. If you have any more questions about it, I won't go into too detail just because I don't want to spend too much time like talking to y'all. Like I just kind of want to get through all the models basically. Yeah, so if you have any more questions, just like reach out to me. I can like try to explain it my best. Or YouTube, Stats Quest, you know, really helpful, really helpful. Okay, let's see exit out of that. So now what we're going to do is we're going to do our confusion matrix of our classification tree. So we are going to do predict, and then we're going to do the predict function tree model new data is equal to our validation, and then again our type is equal to our classification. Boom. All right, now we can, and just to see how accurate we are, we can do our tree underscore prediction is equal to our coaching column. All right, let's see how it did. Oh, wait. Oh, I didn't build the table. My bad. I was like, where'd that go? Okay, table. Our predicted is equal to our tree for prediction, and then our actual is equal to our validation coaching column. Okay, there we go. Let's rerun that. But I can already see it. It didn't do good. Yeah, so it misclassified even more, having to be coached whenever they that it was basically just like relying too high off of the UPH. Yeah, so I mean it's okay. It's kind of cool to learn though, you know, going along and just saying whether or not it can still accurately classify new observations of data correctly using something else. Normally, if I were like to move on, I would basically assign people that need to be coached strictly off productivity. But the fact that it's using other, it's only using performance, not productivity, I think that's pretty cool that it's still able to do that. So let's go ahead and move on to the very last thing we're doing a random forest. A random forest is basically just 1,000, uh, or however many. It's like a lot more. It generates a lot of these. Let me just pull up a picture. It generates a whole bunch of these. And what that does, the reason why it usually makes it more accurate is that it prevents overfitting. Just the fact that it's only going off of one data set, and it's generating one tree based off of one thing of training data, it tends to overfit. And so with the regression tree, it kind of helps prevent that. Okay, so let's go ahead and move on to the very last thing, which is our random forest. Okay, and then I have to call my library random forest. This is the function that we're going to be using. Let's do a random forest model, and then it's going to be and I guess this one follows something very different. So you have to specify that it's category your dependent variable is it's a English. Okay, it's a category. So that's what we're doing for our coaching column here. Besides that, everything else is gonna follow the same format. Data is equal to train. Importance is equal to true. I don't know why you have to do this, but you do. Let's do number of trees. Let's set that equal to 1,000. One downside to random forest is its computation time, but it's not really an issue here just because we're dealing with an extremely small data set. That's only like 150 rows of data. If we were dealing with like hundreds of thousands of observations or rows of data, then it would take extremely long time. But that's not the case here, so we don't have to worry about how many trees we generate because it'll generate it pretty quickly. And then this is number splits, so we're just gonna do 3. I think I have everything I need. Hopefully, and then let's just test the performance. So we're going to predict it, and we're going to do this. We're predicting our random forest model. New data is equal to our validation, and that's all we need to do there. And then we build our table. Our predicted is equal to our random forest prediction, and then our actual, once again, is equal to our validation coaching column. Okay, and then we can test the accuracy of it. Tree underscore predict is the same as the validation coaching column. Okay, let's run that. Let's see how we did here. I'm expecting it's going to be better than the classification tree, but not as good as the logistic regression. Let's see if I'm right. No, it was actually just the same as the... That's really interesting. It basically did the exact... It only got one better. That's really interesting. Okay, as you can see, I guess random forest didn't do better. I'm gonna do one more thing really quick. I'm going to do a variable importance plot just so we can see which variables it's taking to like the most significance, like which variables it's saying are the most important whenever it's classifying partners as needing to be coached. So variable importance plot, and so it's this, and then we're doing what I call it again? It's not that. Oh, I guess it is RF model. Okay, let's run that, and there we go. So as you can see, This side is basically saying, okay, if you were to remove one of these variables, how much would it decrease basically the accuracy of the model? And so according to this, if you take away UPH, it would decrease the accuracy the most. And the next important one is the shop time, and then units shopped, and then it doesn't really take into account much of the Kirby stats. I guess just because we usually have less Kirby's. And then sub is short. This is sub and short percent. It's a percentage sign. That's why it's not showing up here. Um, and then this side is basically the importance, basically like ranking them on importance. It's following the kind of similar format. UPH is still way at the top. Um, and so I guess that pretty much sums up everything. I'll just go over what I learned from doing this. What I learned from doing this is that um, whenever you build your own artificial classification column and it's strictly based off of something that like you already know what it's all based off of. If you're trying to classify it with other variables and not including the one that is very important, it won't be as accurate. Obviously, I'm assuming if I were to have included the productivity column in here, it would be a different story. It'd probably be like very high. But I don't want that. I just wanted to test and see whether or not I can come up with an efficient classification method of whether or not we need to coach partners strictly off of their stats. And honestly, I feel like that would be a better way of approaching how we should coach partners. I feel like productivity percent doesn't really, it's like very noisy, as I said earlier, and classifying partners as needing to be coached just because we have partners that may be very helpful and be working really hard, but they might be doing stuff that's not contributed to shopping or grabbing Kirby's or anything like that. They could just be like helping with returns, helping cleaning, or helping with customer assistance, or putting returns back, or left behinds. We have partners that do that a lot, and that might not reflect in their productivity, and so that might not be a very fair thing. And so maybe we can find a new way to approach coaching partners. I'm not saying that this would be a better way, but maybe we can eventually find a more effective way in coaching our partners. So yeah, that's basically it. As we learned, the logistic regression was also the most accurate at 71%, which is to be expected. Um, so yeah, I guess that's pretty much it. If you have any other questions about it, feel free to reach out. And I had a lot of fun doing this, and I hope y'all got something out of this as well. Hopefully, I'm still getting used to explaining things and I guess teaching, and so I might not be the best right now. Hopefully, I can improve. And if y'all have any recommendations on how I can improve myself, I'd really appreciate it. So yeah, that's basically it. I'll see y'all later.